Download this code from codegive.com, link in the description below. Designing APIs, Less Data is More, a deep dive inspired by Damir Svrtan. This tutorial explores the principle of less data is more in API design, drawing inspiration from the philosophy advocated by engineers like Damir Svrtan. We'll cover why this principle is crucial for creating robust, maintainable, and performant APIs, and how to apply it in practice with code examples. The core idea: why less data is more. The less data is more principle suggests that APIs should strive to return only the data explicitly needed by the client. This seemingly simple idea has profound implications. Improved performance. Smaller responses translate to faster transfer times, reduced bandwidth consumption, and lower server load. This directly impacts the user experience. Enhanced security. Minimizing the amount of data exposed reduces the attack surface and the risk of inadvertently leaking sensitive information. If the client doesn't need it, don't send it. Increased maintainability. Smaller, well-defined API contracts are easier to understand, evolve, and maintain. Changes to internal data structures are less likely to break client applications if the API doesn't expose everything. Better user experience. Clients process and display less data, leading to faster rendering and a smoother user experience. Reduced coupling. APIs that return only what's needed minimize the coupling between the server and the client. This allows the server-side implementation to evolve independently without affecting client applications as much. Cost optimization. Less data transferred translates to lower costs associated with bandwidth usage, server processing, and storage. The problem: the temptation of overfetching, the God Object API. The opposite of less data is more is the God Object API, which returns large, complex objects containing far more data than the client actually needs. This often happens for several reasons. Laziness. It's easier to simply serialize the entire database record and send it back than to carefully select the necessary fields. Anticipation. Developers might anticipate future needs and include extra data just in case. This is premature optimization and can lead to unnecessary bloat. Lack of understanding. The API designer might not fully understand the client's needs and inadvertently expose too much data. Practical techniques for less data API design. Here are several practical techniques you can use to design APIs that adhere to the less data is more principle. 1. Field selection. Sparse field sets the field's parameter. This is arguably the most common and effective technique. You allow the client to specify exactly which fields they need in the response. This is often implemented using a field's query parameter. Code example: Python with Flask and a hypothetical user model. Explanation. Fields query parameter. The client specifies the desired fields in a comma-separated list in the URL, example /users/1, fields equals ID, username, email. Field selection logic. The code extracts the field's parameter and creates a fields underscore list. It then iterates through the requested fields and includes them in the response only if the field exists in the user underscore dict. This provides resilience against invalid field requests. Default behavior. If the field's parameter is not present, the API returns all fields. You can configure this differently if you prefer, example always require a field's parameter. Error handling. Implicit. While we don't have explicit error handling for invalid field names, the if field in user underscore dict check prevents the server from throwing an exception if the client requests a non-existent field. More robust error handling could return an error message to the client indicating invalid fields. Asterisk schema, Marshmallow. We're using Marshmallow for serialization. While not strictly required for this example, schemas are essential for validating input, serializing data, and ensuring data consistency in more complex APIs. Marshmallow also provides features like only and exclude that can be used instead of manual field filtering. Example requests asterisk get/users/1, fields equals ID username, returns only the ID and username. Get/users/1, fields equals email first_name last_name, returns only email, first name, and last name. Get/users/1, returns all fields. Advantages of field selection highly flexible clients have complete control over the data they receive. Easy to implement relatively straightforward to implement in most frameworks. Disadvantages of field selection verbose URLs URLs can become long and unwieldy with many fields. Client-side logic clients need to understand the available fields and construct the correct URL. Potential for abuse malicious clients could request an excessive number of fields, potentially impacting performance. Consider setting limits on the number of fields that can be requested. 2. View-specific endpoints, resource projections. Instead of having a single endpoint that returns all fields, create multiple endpoints tailored to specific use cases. Each endpoint returns only the data required for that particular view or function. Example, Python with Flask. Explanation separate endpoints we've defined /users/user_ID/profile for user profile data and /users/user_ID/contact for contact information. Specific data each endpoint returns only the fields relevant to its purpose. Advantages of view-specific endpoints clear API contract the API contract is very explicit about what data is returned for each endpoint. Reduced complexity clients don't need to specify which fields they want. Can be more performant if the server can optimize data retrieval based on the specific endpoint, example by querying a different table or using a different index. Disadvantages of view-specific endpoints increased complexity the server-side code can become more complex with multiple endpoints. Code duplication there may be some code duplication between endpoints, example getting the user object. This can be mitigated with helper functions. Less flexible clients have less control over the data they receive. If they need a combination of data from multiple endpoints, they have to make multiple requests. 3. GraphQL. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. It allows clients to ask for exactly what they need and nothing more. It's a powerful alternative to REST-style APIs that can effectively address the overfetching problem. Key GraphQL concepts schema a description of the data available through the API. It defines types and their fields. Query a request from the client specifying the data they want. Resolver a function that fetches the data for a particular field. Example, Python with Graphene and Flask. Explanation Graphene we're using Graphene, a Python library for building GraphQL APIs. Schema the user type defines the structure of user data. The query type defines the entry point for queries. Resolvers the resolve_user function is a resolver that fetches the data for the user field. Note the example of a conditional resolver in resolve_email that might restrict access. Flask GraphQL We're using Flask GraphQL to integrate GraphQL with a Flask application. GraphQL GraphQL is an in-browser IDE for exploring and testing GraphQL APIs. Example GraphQL query This query requests only the ID, username, and first name fields for user with ID 1. The GraphQL server will only return those fields. Advantages of GraphQL Precise data fetching clients can request exactly the data they need, minimizing overfetching. Strongly typed The schema defines the data structure, providing strong typing and validation. Introspection Clients can query the schema to discover the available data types and fields. Single endpoint typically uses a single endpoint, example /GraphQL, simplifying API management. Security GraphQL resolvers allow for fine-grained control over which users can access which data, enhancing security. Disadvantages of GraphQL Complexity GraphQL is more complex to set up and learn than simple REST APIs. Overfetching Potential poorly designed GraphQL schemas and resolvers can still lead to overfetching. It's crucial to design the schema carefully and optimize resolvers. Caching Caching strategies can be more complex than with REST APIs. N+1 problem The N+1 problem, making N+1 database queries to fetch related data, can be a concern with GraphQL if resolvers are not implemented efficiently. 4. Aggregated endpoints, backend for frontends, BFF. This pattern involves creating separate backend services tailored to the specific needs of different front-end applications. Each BFF exposes an API that returns only the data required by that particular front-end. Scenario Imagine you have a web application and a mobile application, both displaying user information. The web application needs a lot of details about the user, while the mobile application only needs a few basic fields. Implementation Web BFF a backend service specifically for the web application, exposing an API that returns all the necessary user details. Mobile BFF a backend service specifically for the mobile application, exposing an API that returns only the basic user fields. Advantages of BFF optimized for each front end each front end receives exactly the data it needs, minimizing overfetching. Reduced complexity the front-end applications don't need to implement complex data filtering logic. Improved performance smaller responses lead to faster loading times and a better user experience. Independent evolution each BFF can evolve independently to meet the changing needs of its corresponding front end. Disadvantages of BFF increased infrastructure complexity requires deploying and managing multiple backend services. Code duplication there may be some code duplication between BFFs, although this can be mitigated with shared libraries or services. 5. Pagination and limiting results. When dealing with large data sets, it's essential to implement pagination to avoid overwhelming the client with too much data. Techniques limit and offset parameters allow the client to specify the maximum number of results to return, limit, and the starting point, offset. Cursor-based pagination use a cursor, an opaque string, to track the current position in the dataset. This is more efficient than offset-based pagination for large data sets. Asterisk links header asterisk include link headers in the response to provide URLs for the next, previous, first, and last pages of results. Example, Python with Flask. Example requests asterisk. Asterisk get slash items, limit equals 20 and offset equals 0, returns the first 20 items. Asterisk get slash items, limit equals 10 and offset equals 20, returns items 21 to 30. Asterisk get slash items, returns the first 10 items, default limit. Key considerations asterisk. Asterisk default values asterisk provide reasonable default values for limit and offset. Asterisk validation asterisk validate the limit and offset parameters to prevent abuse. Asterisk total count asterisk include the total count of items in the response so the client can calculate the number of pages. Asterisk metadata asterisk include pagination metadata, limit, offset, total count, in the response headers or a dedicated meta section. 6. Data transformation and aggregation. Sometimes, the client needs data in a different format than what is stored in the database. Perform data transformation and aggregation on the server side to avoid sending raw data to the client. Example asterisk. Instead of sending a list of individual sales transactions, aggregate the data by month and send a summary of monthly sales. Benefits asterisk. Asterisk reduced data transfer asterisk sending aggregated data is often much smaller than sending raw data. Asterisk improved client performance asterisk the client doesn't need to perform the aggregation itself. Asterisk decoupling asterisk the client is shielded from changes in the underlying data structure. 7. Versioning, evolving APIs gracefully. As your API evolves, you may need to make changes that are not backward compatible. Use versioning to allow clients to continue using older versions of the API while migrating to newer versions. Versioning strategies asterisk. Asterisk URI versioning asterisk include the version number in the URI, example /v1/users, /v2/users. Asterisk header versioning asterisk specify the version number in a custom HTTP header, example accept version, v1. Asterisk media type versioning asterisk use different media types for different versions, example application/vnd.example.user.v1 plus JSON. Benefits asterisk. Asterisk backward compatibility asterisk existing clients can continue to use the older version of the API. Asterisk controlled migration asterisk allows clients to migrate to the new version at their own pace. Asterisk clear API contract asterisk each version has a well-defined API contract. 8. Compression, xip.ly. Even after minimizing the data returned, consider using compression to further reduce the response size. Xip and .ly are common compression algorithms that can significantly reduce the size of JSON responses. Most web servers, example Nginx, Apache, support compression out of the box. Code example, Flask with xip compression. Important considerations for implementing less data is more. Asterisk understand your client's needs asterisk the most important step is to understand exactly what data your clients require. Talk to your clients, analyze usage patterns, and gather feedback. Asterisk prioritize performance asterisk measure the performance of your APIs and identify bottlenecks. Use monitoring tools to track response times and data transfer rates. Asterisk document your APIs thoroughly asterisk clear and accurate documentation is essential for clients to understand how to use your APIs effectively. Asterisk embrace iteration asterisk API design is an iterative process. Start with a simple API and evolve it based on feedback and usage patterns. Security is paramount. Never expose sensitive data that is not absolutely necessary. Implement proper authentication and authorization mechanisms to protect your APIs. Monitor API usage. Regularly review which fields are being requested and how often. This will help you identify opportunities to optimize your API further and potentially remove unused fields. Conclusion: the benefits of a lean API. By embracing the less data is more principle, you can create APIs that are faster, more secure, more maintainable, and more user-friendly. This leads to a better developer experience, improved application performance, and reduced infrastructure costs. Remember that API design is an art and a science. By carefully considering the needs of your clients and applying the techniques discussed in this tutorial, you can build APIs that are truly effective. Just like Damir Svrtan, always ask yourself, does the client really need this data? If the answer is no, leave it out.